So now let's look at a cylindrical to rectangular conversion problem. So let's look at the following example. I want us to find an equation in rectangular coordinates for the surface represented by the cylindrical equation r squared cosine of 2 theta plus z squared plus 1 equals 0. So the first thing that kind of jumps out at me is I don't just have cosine of theta, I have cosine of 2 theta. So we need to use an identity for that. We need a double angle identity formula. And so that is the same thing as cosine squared of theta minus sine squared theta. And then I'm going to go ahead and distribute this r squared here. So this will be r squared cosine squared theta minus r squared sine squared theta plus z squared plus 1 equals 0. Well, r squared cosine squared, this is just x squared, because x is r cosine theta. And then this over here, that's just y squared. Y is r sine theta plus z squared plus 1 equals 0. So you could stop here because we've converted the equation, but maybe we want to identify what kind of surface this is. So I see that I have this constant term 1 here. Let's move it to the other side. And it would be a -1. But in that table, we needed this constant term over here to be a +1. So multiply everything by -1. Negative x squared plus y squared minus z squared equals 1. And if you look at your chart, you'll see that this is a hyperboloid of 2 sheets, and it goes along the y-axis. The one with the positive coefficient lies along the y-axis. So your 2 bowls that point outwards, they're going to point out on the y-axis.